Hey, what's up guys? Got another tip for you. So if you're trying to determine the refrigerant charge, or if the refrigerant charge is adequate, I should say, you need to be putting these in test mode. What test mode does is it ignores all of your set points. So we're going to put it in test cool, and if we have the thermostat set for 75 and we keep it in test mode and it cools down to 70, it's not going to turn anything off. It's going to keep the system running, and it'll also keep valves from moving around too much. It'll kind of make your compressor settle into a stable frequency, and just keep things from moving around. These things are extremely variable, hence the name variable refrigerant flow. So they're a moving target, to say the least. So if you're coming up to a system and you think it's low, but not super low because things don't look too hot, what you need to be doing is putting it in test mode. So how you do that is you come up to the main board. You can see we've got a lot of dip switches. You need to turn SW10 on SW6 to on, and then on SW4 we need to turn 2, where is it? 2, 4, 5, 8, 9, 10 to on. Now this screen up here, probably not showing up on the camera, but it says 922, and that is test mode. Okay, so get that all set up, and then what you're gonna do on maintenance tool, so you're gonna come over to drive operation, indoor coil, or IC. This screen is gonna pop up. Now, I only wanna control the indoor units that are connected to this one system. So we're gonna select 1 through 6. And we're gonna come up to stop. We're gonna transmit that. Now this is gonna tell all of our indoor units to stop. Now if you have a building automation system connected to this and you have centralized controllers inside, you need to pull off the, I believe it's LAN 2 on your central controller. Otherwise, when you put it in a test mode, a lot of the times the building automation will kick it back out. So now we've stopped all of our indoor units. Now we come back up to our main board and we hold this button right here until LED 3 turns on. Okay, just turned on. Come back down. We're gonna put it into test run and cool. We're gonna transmit that. So now it'll run into test mode. It'll ramp up. It's gonna ignore all the set points. It's not gonna move around as much. You'll be able to look at your SC1 and SC6, watch your TH4, watch your TE, just be able to determine if the system is a little bit low on refrigerant, maybe it's overcharged. So this is gonna really help you determine that. I believe that's really it. This system is going to run in a test mode for about 30 minutes. It says 2 hours, but I was talking to someone with Mitsubishi a while ago and he said that's not the case. It's only going to run in test mode for about 30 minutes. It'll stay in test mode, but apparently it just starts to let things move around more. So watch it for about 30 minutes is your maximum, and then you might need to turn it back off, put it back into test mode, go from there. Now what you're watching for is, like I said, your subcooling. So you want to watch your subcooling on your SC1 and SC6. It's just like a regular split air conditioner. You want to have subcooling because that tells you what your refrigerant's doing. Now SC1 you want between 9 and 27, and SC6 you want 27 to, I believe it's 54. Now SH2 is your superheat after your 2 subcoolers. See if I can show you, because that sounds pretty confusing, I'm sure. So these 2 are your subcoolers. First subcooler, second subcooler. Okay. Now this LEV is sending saturated liquid to your subcoolers. And you want to see 4 degrees subcooler or superheat after your 2 subcoolers. Okay. So you have hot refrigerant coming out of your first subcooler, and then coming out of your second subcooler. We're going to take some of that liquid off, and this is in cooling only. Through this LEV, you're going to flash, boil off, pick up heat, and then pick up more heat, and then go back to your outdoor unit. So you want to see subcooling there. If you don't, then you could have low refrigerant or another problem, but most of the time you're going to have low refrigerant. So SC1, SC6, 9 to 27, 27 to 54. SH2, you want to see about 4 degrees. Superheat on your indoor units, you want to see 0 to 15. And your TH4, your discharge temp on your compressor, you want to see in cooling only below 180. Mitsubishi says 200, but most of the time, 9.5 times out of 10, I see it below 180. It's usually around 150. If you're low on charge, what you'll see is no subcooling at SC1 or SC6. SH2 will have a lot of superheat. TH4 will be 180 plus. So basically what that's saying is your discharge temp on your compressor is hot because your TH5, your temperature coming back to the accumulator and then to the compressor, is probably quite hot. So you're sending already extremely superheated gas back to your compressor. It's not cooling it as much, and then you're getting extremely high TH4 discharge temp. So like I said, you got to wait for it to settle in. If it's extremely low, you should be already able to tell before you even put it into test mode. But if it's just a little bit low, or maybe if it's overcharged, maybe you're getting 1500 overcharge errors, you just want to see by how much. So, and while we're on that subject as well, refrigerant charge is extremely important on these systems. Also, they do a little bit better undercharged than they do overcharged. This system could have 150 pounds in it, and it could be running off 50 pounds. It's not going to throw any errors, or you might throw a hot discharge temp alarm, but this system will essentially run itself into the ground when it's low on refrigerant. Now, when it's overcharged, even by 10 pounds, your TH15, which is mounted on the compressor shell, it's just mounted at the bottom of the compressor, just down here. It will see that you're pulling liquid from your accumulator. So right here, you could be pulling liquid from your accumulator over, and it's going to settle in the bottom of that compressor. Your TH15 is going to get extremely cold, and it's going to say, hey, I probably have liquid in my compressor, I need to stop. You'll sometimes get nuisance alarms for that. But like I said, try to shoot. If you don't know the total charge, which is sometimes the case if someone doesn't have a DSB or someone didn't write the total charge on the system, it's extremely hard to determine. Besides measuring line lengths and building your own DSB, it's extremely hard to determine the refrigerant charge. Now, like I said, these systems are extremely sensitive. They need to have the correct amount of refrigerant. Otherwise, you could kill compressors, or you're just not going to run right. So, just make sure that you know the total charge, and that when you put it in test mode, everything looks great. I believe that's it for this one. Let me know if there's anything else you guys want to see. Otherwise, I'll just be making kind of random videos about this and that here and there. So, yeah, let me know what you guys think, what you guys want to see, and we'll go from there.